All right. Well, welcome everybody to the webinar from wherever you are connecting from around the world. We're really glad to have you here for this lower energy consumption and better performance with optimized aerodynamics webinar, sponsored by Altair. Our speaker today is Corey Sukup, and I am going to turn it over to Darius Fadnelli from Altair to say a few words and kick us off. Darius, over to you.
Thank you, Randy, and thank you everyone for attending today's session. Altair is really happy to partner with ASME and the Digital eFest this year, and Altair has been a big fan of simulation being part of making better decisions and making better products. So this contest really tries to show that by using simulation, you can actually exceed your goals and make better vehicles and better products. Corey, who will be presenting today, has done multiple of these presentations for many different type of teams, whether it's super mileage teams, formula car teams, senior capstone teams, etc. I think you will learn a lot from him. He's used CFD in his background, both in school and at Altair, and you should be able to pick up a few tricks of the trade to hopefully make your designs even better. Please reach out to Altair if you are participating in this contest to get help in the future, and we will be able to provide you feedback so you can continue to use our tools in the future. Without taking more time away from Corey, please enjoy today's session and looking forward to seeing some of your designs that we get to judge. Thank you, Corey.
All right, thank you, Darius. Hope everybody can hear me okay. I'm gonna go ahead and start by just getting the right share settings here. All right, so I hope everyone's having a good week. Like they said, my name is Corey Sukup. I'm an application engineer at Altair. A little bit about me. I graduated from the University of Minnesota in 2019. Got my degree in aerospace engineering there, and then joined Altair upon graduating. So I'm coming up on just about 2 years now with Altair. My primary focus being structural FEA, more specifically composite design and optimization. Like Darius said, I do have some background in CFD, mostly from my university days. But with that being said, I don't claim to be an expert necessarily in CFD. So if there's any questions you guys have at the end that I can't answer, I'll make sure I do the research needed to find the answer, or else get you in touch with someone more qualified to answer that for you. But I'll do my best to answer everything quite generally. So the tool I'll be presenting today is called Virtual Wind Tunnel. If you guys are not familiar with it, it is a very simple, user-friendly tool, really designed with the student in mind. And when you open it up, you'll see what I mean. Everything's right there. It's laid out in front of you. There's really no training required. It's very simple, very laid out, and you'll see when I get that open here in a minute. So let's just go ahead and get started here.
If you don't mind, Corey, if I may add one point here. To get Virtual Wind Tunnel, you do have to sign up for the sponsorship with Altair. That way you get access to all our tools, and you'll be able to also get as many licenses you need for your team. So if you have 2 members or 22 members, it doesn't matter. Everybody can get a license. But the key thing is since Virtual Wind Tunnel leverages the full version of our CFD tool, you'll need to sign up for sponsorship to get that. The free student edition does not come with the Virtual Wind Tunnel, but the free student edition has many 26 other of our tools in it, except this one. So please just be aware, if you have any issues with signing up for that, please let us know. Even if you're just in 2 of you, that's fine, no worries, but that's what you'll need to do.
Yep, certainly. Thanks for that. And if you guys need any help with that, you're more than welcome to ask at the end. I can provide some links as well. So I've planned this presentation to be roughly an hour. We'll probably go a little over that. And that's just to give you guys plenty of time to ask me questions you have so that we can help you the best we can. If there are not too many questions, I do have some extra content planned just to show you some other tips and tricks that you can use along with Virtual Wind Tunnel to improve your designs aerodynamically. So here's a brief overview of my agenda here. I want to talk about the history of aerodynamics, a little bit about CFD, why it's important, why we use it. I'll go through a demo of Virtual Wind Tunnel, talk about the workflow that's required. And then at the end, like I said, if we have time, I'll go through some tips and tricks, but I'll most certainly show you some post-processing tools that we have available as well. And all of those should be available in the free student edition. So, all right, so what you're seeing here is a formula car pictured at the bottom. External aerodynamics is pretty important for a variety of reasons. We've got our engine cooling, our brakes cooling, performance. Power to drive is going to be critical for a lot of the designs you're working on, I'm sure. Emissions stability is something that has certainly given me nightmares in my university days. If you're driving a very lightweight student-built vehicle across an open plane, those crosswinds can become a bit dangerous. So it's important to keep that in mind and plan for it ahead of time. Obviously, comfort, ventilation, your heating, visibility is more important in races like Baja. But certainly a big part of CFD these days. Out of CFD, these are the two primary values that we're trying to achieve. We're trying to get out of our simulation, our lift and our drag, right? And so in a race like Formula Car, in this example, we want as much negative lift as we can. Downforce is very important. We want to keep that car firmly on the ground so that it's not flying off the road when we go over the crest of a hill, for example. Aero Acoustics, another big piece of CFD these days. We're seeing more and more commercial users getting into using CFD for Aero Acoustics and keeping that cabin noise quite quiet, things like that. So here I'm probably preaching to the choir on this slide here. But we know that drag force is very important. It accounts for roughly 75 to 80% of our total car resistance, of our vehicle performance. The simple drag equation that you see there is what we learned day one in aero engineering. It's 1/2 rho v squared times your CDA, rho being the density of your fluid domain, v being the velocity of your vehicle body relative to that fluid domain, the fluid outside of it. And your drag coefficient and your area are the two values that you're really controlling when you design your car. The frontal area, as you see pictured here, typically in automotive cases, we're going to be using the frontal area, and that's just taking a cross-section view from a front perspective and plugging that area in right there. If you're working on an aircraft, for example, you're going to want the planform view. That's a top-down view looking at the wings. In some simple cases, you're actually going to want to use the wetted area, the total surface area of your model. But that's only in cases where you know it will be a pure laminar flow. So in 90% of the cases, I would say you want to use frontal area. Your car shape is very much, or your drag coefficient is very much controlled by your car shape. So, if you design a vehicle that's, of that typical teardrop airfoil shape, you reduce the wake behind your car and therefore reducing the form drag, you're going to improve that CD value. There's other things involved in that, such as skin friction, but it is very much an all-inclusive value and very important to consider. Your lift force, we all know lift happens when we have higher pressure below the body than above the body. It does impact steering quite a bit, like I mentioned before. So here's kind of a catastrophic example of a Formula car being thrown up at the crest of that hill there. So definitely something to consider.
Corey, if I can interrupt, there's a good question about the use of virtual wind tunnel. I don't know if you can take a minute to answer it. I can read it to you so you don't have to change your monitor. The question is, can virtual wind tunnel be used to simulate a CFD flow analysis of a small scale wind turbine system, or is it only optimized for automotive applications?
Okay. Yeah, certainly. Virtual wind tunnel is not just for automotive. You can use it for really any simple use case. There are some things, some limitations, like you can't add a vortex or a swirling gust of wind into your vehicle from the side. You'll have to model that in another tool. But it's very much capable of running any model, not only automotive. And of course you can change, if you're modeling a wind turbine and you needed to capture the wind coming from a variety of different directions, you can certainly change the yaw angle of the airflow coming in. So yeah, very capable.
Could you also, when using virtual wind tunnel, when you set it up and you realize you needed something else from it, be able to take the existing model and then read it into that other tool? And if so, what is that?
Yep. If you need to achieve further post-processing results, you can actually bring it into Hyperview, which is another one of our post-processing tools, and get further answers there. You can also, there is some customization you can do inside of our AcuSolve, which is the solver behind the scenes, but that would be a little bit more advanced than what I'd be talking about today, but certainly possible.
Thank you, Corey.
Yeah. All right, so this chart here just kind of shows that for every vehicle body, for every model that you're analyzing, there's going to be that intersection point where your aerodynamic resistance overcomes your rolling resistance. I don't want anyone to get caught up on this 70 kilometers per hour. This is going to be very different for every use case. This is for a typical automotive use case. For example, if you were designing your body with very thin tires, like I'm sure most of you, some of those bike designs are going to have very thin tires. Your rolling resistance is going to be much lower, and therefore this number is of course going to change as well. But before your competition comes, it's important that you find the intersection point so you can strategize your plans ahead of time. Just seed another question come in. What is the grid generation strategy? Actually, refinement. Is the grid generation fully automated or is it customizable? So the grid generation is customizable, but it's also fairly automated as well. So by default, Virtual Wind Tunnel does a very good job of creating that mesh, creating that grid for you. The inflation layers, all of that stuff, but it is fully customizable as well. And you'll see that part of that meshing, part of that prep comes before you even import it into Virtual Wind Tunnel. But yes, it is both automated and customizable.
And you'll be showing some of that too when you go into the tool.
Yes, certainly. Yeah. Yep. All right, so a little bit of history here, aerodynamics. I can get the slides going again. We saw back in the 30s, people started implementing the airflow shape into their vehicle designs. We see here, they started putting airfoils together in a normalized fashion. And then in 37, we saw two airfoils coming together to form a common trailing edge, and still seeing that in a lot of vehicles today, like the 95 Porsche here. And that's when we first started seeing our CD values coming out very low. But then as the years progressed, safety regulations took over, cars became more boxier, more practical, and those CD values went up. But as engineers, as we started to learn how to include CFD inside of our everyday designs, those values started to decrease again. We still see cars like this Honda Insight or even the i3 that are very boxy cars. They're meant for inner city travel, more practical, if you will, and not so much designed like the BMW i8 down here is more designed with a lower CD to capture a higher performance at higher speeds. This is just sort of a fun side that we typically throw in some non-automotive values. The Boeing 747 achieves 0.031 CD. Now this can't really be compared apples to apples to an automotive case. Like I said, this frontal area is actually calculated using your top view planform area. So of course, with a larger area, this value is going to be a little bit smaller. But you can see that use case there. We've got the Eiffel Tower, roughly 2, an upright man around 1. And then we actually have a coworker who ran this study just this last year and got a CAD value of 0.2 on a cow. So if you're ever in trivia and someone asks you that, now you know. All right, so this is the source of drag on a modern car. Typically we see, most people know that majority of our drag comes from the top half of the vehicle, and that's what we're modifying most of the time. But what some people don't realize or don't try to look into right at the start of their designs is that nearly a quarter of our drag comes from inside the wheel wells. And that's why we see in more recent cars the implementation of air curtains, which sort of skirts that air around the wheel wells and keeps that boundary layer, that air outside of that wheel well, so we can avoid any of that recirculation. I'm just seeing a bunch of questions pop in. Those don't look relevant. Okay. All right, so here's kind of the steps we take to run a typical CFD model. Again, some of these numbers I don't want you to take to heart. It is flexible depending on your use case. But for an automotive case, again, typically it'll be up to 4 weeks in industry for cleanup and surface meshing. That's just prepping your model to bring into CFD. You'll see in a bit here that the solver behind Virtual Wind Tunnel is very robust. And inside of our meshing tool, Hyperworks, it's very simple to mesh apart and prepare it. So that 4 weeks, that's something that you guys shouldn't be worried about. Again, the shell mesh, the number of elements you see there, that's gonna also depend on the size of your model, the dimensions, those sorts of things. The important things here to look at are your first layer height. You wanna capture a Y plus value. Again, this is gonna vary, but typically for any slower moving vehicles, like most of your use cases, you're gonna want around 10, 10 to 30, I would say. For something like a wind turbine, I know someone had asked about that. You might want a Y plus value of closer to 100. So maybe a value of 80 would be good for you. If you're not familiar with this surface Y plus value, the best way for me to describe it is it's a measure of the distance from okay, so when you create the inflation layer to capture your boundary layer outside of your model, you can imagine a mesh being placed on that boundary layer, and as the mesh grows outside from the car's surface, the element sizes are getting larger and larger, and your total distance from the inside node to the furthest outside node of that inflation layer is your surface Y plus value. So it's very dependent on your Reynolds number, and you can control that by changing both the number and size and growth rate of your inflation layers. And I'll also explain that when we open up the tool. That other stuff I wouldn't worry too much about. It's not too relevant here. These I would note down. This is very important information to include here. We do want about 3 car lengths in the front, 7 car lengths to the rear. And that's for, any model that you're running. You want 3 bodies in front, 7 bodies to the rear. Don't worry too much about the 2%, but you want to have as minimal blockage as you can for your inflow area. Creating our surface mesh, typically we use triad elements when dealing with CFD, and that's just because it is a lot quicker. It's a lot more simple, easier to capture some growth from all of the edges of our model. And again, some more information about our boundary layers and surface Y plus values. Now this probably isn't too relevant for most of you, but I've just captured here on screen all of the, now these are just the CFD tools that we offer, both in-house and our partner products. And the reason I point this out is because all of the Altair tools, which you see from this corner and up, Virtual Wind Tunnel being this one here, all of those tools fit into these 3 categories. And each of these categories is run on a different solver. We've got our general purpose CFD, which is run using AccuSolve. External Aerodynamics uses UltraFluidX, and particle-based uses NanoFluidX. For today, I'm going to focus my attention on just these 2 on the left here. The majority of you, I would expect, are going to be using AccuSolve. If you do have access to GPUs, UltraFluidX would be preferred, and I'll explain why shortly. But just for now, I'm going to focus on those 2 solvers here. AccuSolve, like I said, it's a general purpose solver. It's meant for unstructured flow. It's very robust, accurate, fast. It does use second order for all of your models. I say almost no element quality requirements here because it is very robust. You don't have to worry too much about capturing every little feature of your model, but you still need to make sure that you have some sort or some level of quality to your mesh. You don't want a 3 millimeter element right next to an element that's only 1/10 of a millimeter. That's where you get some numerical instability and likely some convergence issues. So make sure that you've got a decent level of quality, but don't worry too much about spending hours fixing it in every little corner. AccuSolve is very diverse in its applications. So you can use this for FSI, thermal, Aero Acoustics, like I mentioned before. Even radiation is one that's not on here. So very versatile in that way. Now, UltraFluidX, the reason the majority of you likely won't be using this one is because UltraFluidX does require access to GPU hardware. Typically, we find most students have access to CPUs only, which requires you to run AccuSolve. UltraFluidX, if I jump to the next slide here, does run on the lattice-Boltzmann method. It does require GPUs. I should mention now too that the version of Virtual Wind Tunnel I'm going to be demoing inside of is version 2017, and that's because that's our most recent version running AccuSolve. So if you do have access to GPUs, you can install version 2021, and all the better for you. But if not, version 2017.2 is more than capable, and AccuSolve is a fantastic tool as well. So here we've got some other benefits if you do have access to them. Again, it is recommended. You can save time, energy, and cost by running with that over CPU. And here I'm gonna jump into the tool now, and this is a generic workflow that I'm gonna be following as I create this model here. I'm gonna pre-process. So I'll import my mesh from Hyperworks into Virtual Wind Tunnel, set up my boundary conditions, my run parameters. I'm actually gonna be using AccuSolve to run it, and then I'll post-process inside of Hyperview. So again, if you guys don't know, you can write this down, and we can also provide this link as well. It's altair1.com/marketplace is where you're gonna go ahead and download any of these tools. Again, Virtual Wind Tunnel only available if you have the sponsorship, but make sure that you're installing version 2017.2 if you do not have access to GPUs. This is going to be your tool of choice. To get to that, you just want to click on Virtual Wind Tunnel and then make sure you navigate to Suite 2018 and you'll find that version right there for you to download. All right, so just a couple of tips I wanted to point out before opening the tool here. Virtual Wind Tunnel does require a fully enclosed mesh. I mean, really any CFD tool does. You want to make sure that you've got no free edges, that it is watertight. You've got no duplicate or double elements, things like that. Some just generic meshing information that most of you are probably familiar with. Again, CFD, you want more of a surface deviating mesh. So from all of your edges, you want there to be some sort of growth rate from a small element size out to larger elements in the middle of your surfaces. Size and bias has its place in the world of FEA. CFD is not one of them. Surface deviation would be preferred for this use case. Again, this is the general process we're going to follow. Create a watertight mesh. We'll import into Virtual Wind Tunnel using a NASTran format. We set it up using the AcuConsole GUI and then solve using AcuSolve. And then AcuFieldView will generate an automated PDF report that provides us all of those values and results that we're looking for. So very, very handy in that way. Go ahead and open up the tool here. Now this isn't Virtual Wind Tunnel. This here is a tool called Hyperworks. If you're not familiar with it, this is really our premier meshing tool, or all-inclusive FEA modeling tool. I'm just going to go ahead and walk through the simple steps to mesh this part. I'm going to go ahead and open a hypermesh model that I've already created here called Race Car Cleanup. It might take a couple seconds here because I am sharing my screen, but there it is. Looks like we are missing our suspension. There it is. And if I zoom in here, you'll see that this part is already meshed. So you see the growth rate. We've got a finer element size on these corners, and it's growing as we go into the model. Now, areas like this, typically I wouldn't be very happy with. I would want to spend some time correcting that. But for the case of Virtual Wind Tunnel, it's robust enough to handle things like this, and there's no need for me to spend hours going through this model and correcting every little nuance that I see. So this mesh would be just fine for me. How I did this mesh, if you're not familiar with it, you can go right up here to this top ribbon, select mesh. You can select a general 2D mesh this way. If you open up the CFD solver interface, before I go into that, let me show you this tool. So if I just hit F12, or I can go into 2D auto mesh down here in the panels as well. This is where I can get to my surface deviation tools. So if I wanted to, I could simply remesh all these elements using surface deviation. I would select my element size, my growth rate, minimum element size, span angle and feature angle, and then hit mesh. I'm not going to redo that. The reason I meshed it beforehand is because this is a very large model and it takes a good number of minutes for that to complete meshing. So I'll leave the mesh I have here. But just so you know, those are the steps I had taken. Just go into auto mesh, make sure I'm on surface deviation. And I believe for this model, I had a size of 0.01. I'm seeing a question here. Does surface deviation automatically detect regions that require such a meshing? So surface deviation does a pretty good job, but if you want to further refine it, we have something called mesh controls. And if you want to dive into mesh controls, I would recommend taking the Introduction to Hypermesh class. Otherwise, if you want to access those, you can go up here to the now you see how they've changed everything on me. In the old interface, you could get to it up here. I'm not sure how to get to mesh controls in this new interface yet. I have not used that, but that is a tool available. I can look into that for you, but I would recommend taking the HyperMesh class.
Yeah, we also have some online training material on our website. If you go in there, you can see some pre-recorded materials that cover a lot of the features too. So if that's another way to do it, and you can have access to it, whenever you need to. Since usually our classes are, if they're live, are probably during most people's class time. So
Certainly. So I did just find it. It was right in front of me. Just clicking on mesh controls here, and then you can go over here and inside of this model browser, and you can create different regions on your model. Say you can tell Hyperworks that for every radius of X to Y size, I want 3 elements across, and it'll make sure that you've got that sort of control in your mesh. All right, so once we have our mesh, just to keep things moving along here, we want to make sure that our mesh is fully enclosed. So the first thing I want to do is use my check edges tool. I can get this thing to get out of my way here. See if I can move it to my other screen. There we go. All right, so I'm just going to go into validate here at the top. We're going to go to free edges, and that'll open my panel down below. I'm simply going to select all of my elements here on screen. Make sure that I give myself a decent tolerance value, and then find edges. You'll see in the bottom left that it has found 512 free edges in my model. Those are elements that that are not equivalents, they're not connected to any adjacent elements alongside them. So I'm gonna actually open up the component browser here. And I'm going to isolate these. So you can see these are where all of those elements have a free edge. So that's where my model is not fully enclosed. So if I want to make sure that it is fully enclosed, I'm gonna turn everything back on. I'm gonna go back into that same tool, select all my elements. I'll give it a little bit smaller of a tolerance, and I'm gonna say preview equivalence. And we see that it's found about 254 nodes. And we can do a quick check that those nodes are along that free edge there. And then by hitting equivalence, you'll see that it's corrected. So I'll bring my tolerance back to where it was. And we see that now no edges are found. So our model is fully enclosed. The next check we want to do, like we saw on the slide before, is to check that we don't have any duplicate or copies of any individual elements. So to do that, we're going to go just into our element check panel. Again, that's in tool, check elements. I can also just hit F10. And here I'm just going to click on these icons over in the far right. So by hitting on duplicates, I see that there's 103 duplicate elements in my model. I can just go ahead and save those there. Make sure that that worked. And then I'm going to go into my mask panel, and I wouldn't worry too much about these steps. If you really want to get into meshing, again, I would recommend some of those online classes that we offer. And actually real soon will be some on-demand classes as well. I'm just going to hit retrieve. And I'm going to isolate all those elements on screen here. So we see that these are my duplicate elements. Just go ahead and select these. I'll delete those elements on screen. Turn everything back on. And now I'll just check again. And now we see we've got 0 duplicate elements. We don't have any connectivity issues. We can check our edges again. We've got no edges found. So our model would be ready to import into Virtual Wind Tunnel. This is run ready. I'm just reading some of these other questions here. I use OpenFOAM for CFD. OpenFOAM can import Fluent Mesh formats. Yep, so you can actually.
Well, in that case there, Corey, they just wanted to make sure that what Hypermesh could export would work with them. So since Hypermesh exports to ANSYS and Fluent, they'll be fine there. But I just made a note that if they use AcuSolve, once they set up the model correctly in Hypermesh, they just go and run it, within Hypermesh, so they can launch it from there, which will be a little easier to set that up, unless they want to launch it on a HPC type computer.
Right. Okay. So once my model is done, just to quickly move along here, I'm just going to go into export. I'm going to want to export the solver deck. Actually, one thing I need to make sure I do before I do that is change my solver interface to Nastran. And that's to make sure that I can export the correct file format. So I'll go into export and go into solver deck. And I'm going to want to export my file as a Nastran file. I've already got it exported here, so I'm just going to use the one I have, but that's all I'll need to do there. Once I have that model, now I can open up Virtual Wind Tunnel. Now you see here again, I'm using version 2017.2. If you're using the latest version, it's going to look a little bit different. You'll have a lot more variety of options up here. I'm just going to go ahead and import that Nastran file. Right here. All right, so now that I've got the model imported, you'll see that the mesh is no longer visible there. Virtual Wind Tunnel does an interpretation of that mesh, pulls it in and creates sort of a cavity that it's going to be placing inside of your fluid domain. So now what you see here, like I mentioned before, there's really no formal training required, if you will, in this tool. Everything's right in front of you. I'm very confident that any one of you could open this tool up and set up and run your model within 15-20 minutes. We've got our measure tool over here on the left. We can simply go ahead and measure any piece of our model. We can scale our model. We wanted to scale this up to a factor of 2 if we wanted to. We've got our move tool. The first one I'm going to use here is my edit tunnel. When I click on edit tunnel, you'll see it automatically creates a tunnel of a pretty good dimension around my vehicle there. And I can simply control those dimensions by entering new values in here. Virtual Wind Tunnel does a pretty good job of getting a good tunnel size around your model. So you don't have to worry too much about modifying these, but the capabilities there if you need to. So once you've got that tunnel, it's important that you place your vehicle at a good position in the tunnel. So we see right now that it is cutting through the ground of our tunnel. So we're going to want to correct that. It's going to go into a side view here. The first thing I want to do is make sure that my car is in the first third of my tunnel. We'll say right there is pretty good. And then I actually want to have this tunnel intersect my car just at the bottom of this wheel here. The reason I want to have this intersecting is because if I have the ground of my tunnel right here, and we'll say the element size of my model we know is about 0.01. If my element size on the tunnel here is much larger and that inflation layer doesn't grow within that fraction of a space there, we're likely going to get some mesh intersection errors or some convergence issues. So if your model ever is spitting out some mesh intersection errors, this is the first thing I would check. You want to make sure that the ground of your tunnel is just barely intersecting the bottom of your wheels there. A good rule of thumb is to make sure that you've gone up 2 element sizes from the bottom of your wheel there. So for me, that would be about 0.02, and I'd be happy with that placement right there. All right, once that is done, the next icon just to the right of that is my identify parts. And this is where I can identify the different features of my model, such as the boundary layer, my wheels, heat exchanger, or the body. In this case, I'm going to first identify my wheels. And you see it selects both of them here because they are saved in the same component from the original model. And then I can control the direction that they're rotating. In this case, it's already correct. And then that's all I'm going to identify here in this step. Next, I want to go ahead and create some refinement zones. So just by clicking on refinement zone, you'll see that Virtual Wind Tunnel will automatically create a pretty good size refinement zone around my vehicle. Again, this is further customizable. I can just click and drag them. As simple as that. If I want to give it a little bit more space behind the vehicle, which would be recommended. I can further add more refinement zones around different parts of my model. So around body, I can say around parts and maybe select my occupant space here, or maybe my wheels here. If I want to add some further refinement on those front wheels, I can do all that as well. And then over here on the right, you'll see in the property editor is where I can control the element size for these different parts. So if I click on this zone here, you'll see I've got an average element size of 0.05 meters. And I've got it turned on visible. Here my dimensions. And I can look at that information for each one of these zones that I've created here. Just to the right of that is my section cut. Again, very self-explanatory. Can create different section cuts on my model that I want to look at later in post-processing. And probe points can be useful for capturing information or more detail at any specific location on your model. So if I want to capture some information here at the driver's face, maybe the front of my vehicle, inside of this skirt here, or at the rear, I can place any number of points anywhere I want on the model. And you'll see that in the PDF it generates, there will be some additional information that captures each of those probe locations. Then of course, we want to define the material of our fluid domain. Virtual Wind Tunnel by default already has air defined here. If you want to add your own material, you can do that just by using this plus icon and just add a custom density and viscosity and go ahead and do that on your own. But I'm just going to go ahead and select air. And then the final step over here is to set up my run parameters. You'll see along every step of the way, every time I click on something, it opens up this property editor. And that's where I can further refine and customize different parts of my model. For example, if I wanted to click on this body panel here and I check this box, labeling it as flexible, this is going to allow me to bring in an eigenmode file from an OptiStruct setup, and that's it's some further functionality to run some FSI analysis. You can see what the wind is doing to the structure of your body, if you will, and you can set those material definitions and stuff inside of OptiStruct. But everything else is also there for you. Now over here, we've got our run parameters. We can name our run. We'll just name this wind tunnel demo 1. We can select our number of cores, however many you've got. Our inflow speed we can set here. Our analysis type can be steady state or transient. If you choose transient, you'll have to set your runtime and the length of time for each time step. For our demo case, we'll stick to steady state since it is much faster. We'll set our number of time steps. Rule of thumb is 100 time steps is usually a good number. Again, it's dependent on your use case, but typically we see that most problems will converge within 100 time steps if you're running a steady state analysis. We'll define our fluid material. We do want our ground to be moving and our wheels to rotate, which we've defined using this tool up here. And then here we can choose our mesh size. So the far field element size is going to be your elements way out here outside of those refinement zones that we've created earlier. So by default, Virtual Wind Tunnel gives us these 3 options: coarse, medium, or fine. We can also set our own user-defined dimensions. But of course, coarse will run the quickest for us here. We can choose to use an earbody ground refinement. Now in this case, I do have the model intersecting the bottom of my tires, so I would not want to turn this on. This tool is going to be more useful if you're running a model that's maybe floating in a tank of water or something. If you want to make sure that you're refined on the ground there. Where you've got an intersection point, if I had turned this on, it's going to try to remesh the ground of the tunnel here, and we're going to get a mesh intersection error popping up. Here we can specify our first layer height. I like to use 1e to the -5 and then anywhere from 8 to 10 layers. And here we specify our output frequency. For a steady state, you could really just use 100 since we're only interested in the final state, final time step. If we were using transient, we'd probably want to see a full animation of our results. So we could choose an output frequency of 1 or 2 so that it outputs all of that information as it solves. And then the last one here is calculating our frontal area. We can have Virtual Wind Tunnel do that automatically, or we can enter our own value in that box there. If you want to see what Virtual Wind Tunnel calculates as a value for you, you can just click on that lightning bolt to the side there. It does take a couple seconds here, but you'll see that it'll generate a frontal area for you. And that's a good way to double check that you like what it sees. But it is pretty accurate in that sense. All right, so there we go. It's now generated that number, and we can look at that and double check that it's correct, or we can just use the auto here. Next, we either want to export our model if we're trying to run it externally, either on a supercomputer or on a cluster, whatever we've got available. For Virtual Wind Tunnel, though, it's very much designed for the user using a laptop. So in a Virtual Wind Tunnel case, you can just hit run it locally, and it's fairly quick. A simple model will run in 15, 20 minutes. This model, I think, took me about just under a day to run, but I had a very fine element size, as you saw there. Just trying to get some accurate results to show you guys today. but I did run this on my local laptop, no problem. And that's really all that's required inside of Virtual Wind Tunnel. So after you've hit run, Virtual Wind Tunnel actually automatically generates a PDF for you. So let me go in and open up. If you're wondering where I'm finding this, if you go into File Preferences, click on AccuSolve, you can define your run path right here. And this is where it's going to send all of these completed run files. That's where it's going to be stored in your directory. So I'm just going to open up that run path now. And I believe it's this model right here. And we see that this one was run on last week. So this is the one that I had run. And it's output all of our images. We've got our log file in here. So if I open up this log file, you can see everything that it had done while running. And we can take a look at a lot of this information. I had run it on 12 cores. Down here, we can see that we've got about 22 million elements, our node count. And then for each time step here, we can see that, the time it took, about 527 seconds for that time step. And then go all the way to the bottom to see our total runtime, other information that we might be interested in. Another use case for this is, you can always open this up while it's running. It's constantly updating. So if you want to just check in the first 10 minutes that it is running and you're liking what it's doing, that's a good idea rather than waiting 2 or 3 hours and finding out you were missing a step or something. All right, so now what it also generates for you is this PDF. So I'm going to open up this PDF here. We've got our runtime here, picture of our model. Now this is all the information that Virtual Wind Tunnel has provided. We've got our element type, our runtime was 19 hours, our inlet velocity. We've got our drag coefficient, lift coefficient. So we've got some downforce there. Our wind tunnel dimensions, our frontal area, everything is listed for us right here. In this model, I had only done 3 refinement zones, and you can see quick pictures of that as well here. And sort of double check all your work. We've got some component level results here, so we can see that roughly this much of our total drag coefficient value came from the chassis cutout. So that's a good way to break down where your drag is coming from inside of your model. Got all of our pressure plots here. Again, the equations it's using, some contours, streamlines are here. Here we've got a surface Y plus value. It's saying 83.5, which is a little concerning because I would expect something closer to 30 on a model like this. But we do see it is all colored blue, so it must be on the lower end of this spectrum here. So we can see where that max is when we open up Hyperview, try to diagnose that issue. And then of course it's got streamlines, and that's about it. But again, very, very useful PDF, all the information right at your fingertips there. Next, I'm just going to open up Hyperview, which is our post-processing tool. And inside of Hyperview is where I'm going to quickly post-process these results and show you guys what kind of information you can pull out of it. So it looks like I've already got it. Nope, this is not the right one. So in Hyperview, the log file is actually contains both your model and your results from Virtual Wind Tunnel. So I'm going to make sure I get the correct log file in there. Hit apply. and might take a couple seconds here to load in. Again, I know I am working through this very quickly. It is a lot of content to see for the first time in, only an hour. But we're here to help. Obviously, if you guys have questions afterwards, feel free to reach out. So what you're seeing here is just my complete fluid domain. If I want to turn off that fluid, and we'll turn off our entire wind tunnel as well. So we're just left with the components of our vehicle. Zoom in and take a look at that here. We see in the top left that I had requested an output frequency of 20, meaning it gives me an output time step every 20 iterations. So we've got these 5 options here. I'm just going to go to the last iteration, time step 100, so that I get the best results for my steady state analysis. Open up the contour here and take a look at the pressure on our model first. This all looks okay. Maybe we want to take a look at our surface Y plus values. And here we see that our surface Y plus is roughly about 104, which is a little concerning, but we see our model is blue. So why don't we figure out where exactly that problem is occurring? And here I'm just using an ISO contour to figure out where exactly those values are at. We see a colored location right here. If I was to open this back up here, we see it's right underneath inside of the crevice of our model right there. And that's something I wouldn't be too worried about in this case. It's pretty localized and not really going to affect our results too much. The important thing is that we know that everything is pretty low. So we see here that everything is still in the blue range, which tells us that it's pretty close to 0. Now, if I clear this contour, let's take a look at our streamlines. I'm just reading another question here. Is the Mac OS version available for an Altair student team sponsorship, or would the university need a full? I believe it would be available with a team sponsorship. Darius would probably be able to answer that better than I could, but yes, I believe it would be available. All right. Let's open up the Streamlines tool here. We'll select, let me actually turn on, this will make it a little easier. If I turn on my wind tunnel inlet, turn off elements, and make this transparent so that you guys can see through it. All right. So now what I'm going to do is just create a plane. I'll select my dimensions like so. Then I can change the values here. So maybe I'll just double these. We'll make it 8, 10, save that. And then I'll go over here and hit create streamlines. We'll let that load, we'll do its thing. And we can see the streamlines around our vehicle there. If we want, we can try to add some tracers. Do something like that if we want. And we can certainly speed up or slow down the speed of those pulses and see what's happening along each one of those streamlines. So you can see you can do a variety of cool things here. You can actually animate your results as well. If you had run a transient analysis, you could see that in real time. Yeah, that's very quickly Hyperview. I wanted to, if I still have it here. I did mention the Fsi capabilities here as well. That's something that you would need to use OptiStruct for as well. We definitely don't have time to go into that today, but certainly a capability that you guys can look into. Looks like we've only gone through an hour here. I do have some additional tips and tricks, but just to wrap up here, Virtual Wind Tunnel, it is a great environment for external CFD. It's perfect for transient and steady state, very fast, efficient, accurate, robust, great all-around tool. If you guys do want more tutorials, you can actually get to those up in the file page here. On the file and go to help and then open up the tutorials, and you'll get more information there as well if you guys need any additional help. Otherwise, at this time, let's use this time to answer any questions you guys have. And if not, I do have some additional information that might help you guys out with your challenges that I can go through. And I'll just wait a couple minutes here. Otherwise, I'll just jump into that material.
Yep, I just posted in the chat for everyone. If they have questions, please make sure to post them in the Q&A. But Corey, if you have other tips and tricks or anything else you want to add, please do.
Okay. Yeah, so feel free to ask your questions at any time. I'll just dive into this then. All right, so if you're not familiar, we have this functionality called morphing inside of Hyperworks. Now, morphing can be used to quickly change the shape of your mesh without having to remodel it in a CAD package. So if you see in Virtual Wind Tunnel that you've got a lot of drag coming from the tail end of your vehicle body, and you want to try to morph that into more of a teardrop shape and rerun it quickly to see if that helps, you can do that with your mesh and then pull that mesh into well, you can turn that mesh into a geometry using polyNURBS, which, if you guys aren't familiar with, is a geometry creation tool using our Inspire package, which is also part of the student edition. And then that can be pulled into your CAD package and created into your custom geometry. You can tweak it there if you will. All right, so just to demo this, I'm just going to open up another model inside of Hyperworks here. So I'll exit this model. And I'll see if I can find it here. I think it's this model here.
Corey, if you have any links for any of the certified courses, if you want to share any of those or send them my way, I can post them in the chat.
Okay. Yeah, I can do that right after we finish up here. Either while we have everyone on, or I could send them to you afterwards if there's a place we can post them on a website or anywhere there too. So yeah, what we've got here is just a simple sphere, just a surface there. I'm gonna mesh this the same way. We'll use, well, in this case, because we just got a fully round model, there's no clear cut edges. This is a case where I could just use size and bias, right? Because there's nothing, there's no thin parts, there's no thin features that I'm trying to grow my element size from. Every element on this sphere should ideally be the same size. So I'm just going to use my size and bias. I forget what this model size is, but we'll just go with a size of 0.1. Make sure I select my surface. And it looks like that was not large enough. All right, so that's a decent element size for our use case. That'll do. So now if we imagine, we've just brought this back from Virtual Wind Tunnel. We've seen some results that we don't like or we think that we can fix using morphing. I'm going to go into my morphing tool here and just create a quick volume around my part. I'll use this enclose volume tool here. Select all of the nodes in my model and hit enclose. And that's created a sort of box around my entire model. I'm going to use the split combine tool here to split up this model at a variety of locations. So we'll split it in the center here, and we'll also do another split at the center of this here. Oh, looks like I didn't quite get it in the center. But I mean, we can split it however many times we like, all customizable there. And now the simple part is we can go over into this move tool, select any of these handles that we're interested in moving, maybe just those two. And then use this here to just stretch those elements out. And you'll see that as I move these elements, it changes the shape of all the elements on my model so that I don't end up with very poor quality. So it'll kind of stretch all of them evenly, and I can create more of a streamlined shape, if you will. And then go ahead and import that model back into Virtual Wind Tunnel. Morphing is a very computer intensive tool. So if you're trying to do it on a very fine mesh, you'll have to be a little bit patient with it. It can take some time to load between clicks. But again, it's a very quick way to reshape your geometry without dealing with the CAD package. And if I liked this shape, I could then NURB this and pull it into my CAD and then recreate that geometry there. I did have this here ready. So if you guys are also interested, this is the exercise of morphing a sphere and the steps needed to import it back into Virtual Wind Tunnel, run a second check. Here are all the settings they had used in this model here. And then this is to validate those results. So we can see how quickly it run and how accurate it is. And we see down here at the bottom, using these equations, we can validate these results with a real life scenario here, where we get exactly the CD value we would expect of a sphere of those dimensions at that speed. So all there, and I can, if there is a place to post it, I can also post this validation somewhere on the website along with those links, or at the end here if you have time. Something else before I get into this here, something else I would love to show you guys. Where's Hyperworks? There it is. Open up a new model here. Now this is what I'm about to show you guys is a tip that if you ever start running your model in Virtual Wind Tunnel, one of the more common issues I see in competition teams that try to use this is they start their model and it looks fine, and then 10 minutes later it appears as if it's crashing. It'll just stop running. Sometimes you'll get a mesh intersection error, sometimes you won't. But if that ever happens to you, this is more than likely the problem. So I'm just gonna open up, actually import. This model right here. So this is a model from a team that I had been helping in the past, and they had this issue and couldn't figure out what was happening. And I thought it was a great example, so I asked them if I could use it in future talks. Once it loads up here. So 99% of the time when you get those meshing errors, the problem lies in your setup before you import it into Virtual Wind Tunnel. You're actually going to get, if you don't model it appropriately or you don't mesh it appropriately, if you have any free edges in your model, that's what's going to cause a lot of these issues. So if I zoom in here at a bird's eye view, we see it's an incredibly fine mesh. I don't see any problems right away. But what you'll notice if I go into my tool edges, select my elements, I hit find edges, we see that 242 free edges were found. So this model, when they were setting this up, they completely missed the step to check for free edges and later found out that their model was not fully enclosed. So it's not enough to just look at your model and think it looks fully enclosed, because this is what they're missing down here is the edge of one of these lures here was not equivalenced properly. Now, what Virtual Wind Tunnel can do for you is, if you noticed, when I opened up, let's try to find that again. So this is that directory that it had written out to. You see that we don't have the PDF, we don't have the log file, because the model never got started. It crashed before it even got to that point. And it gave us these files called meshintersection.nas or meshintersection.dat. And that's something that Virtual Wind Tunnel gives you to quickly find where those errors or where those issues are happening. So if I wanted to, I could go ahead and import. Just import that meshintersection.nas. So I'll just import another Nastran file. And then you'll see here, if I open up the component browser, then we've got another component that was added down here. So if I hide this top one and zoom in, I could even hide these free edges. You'll see it gives me all of the elements that contained a free edge. So Virtual Wind Tunnel will identify these and then save them in a mesh intersections Nastran format, so that you can quickly identify which elements had that free edge, which was right here. Now, real quick, I can just use the J command to, oh, that's not what I wanted. Hide everything again. should be able to just show the adjacent. But my quick fix solution, just for these here. Here we go. Let's try this. But because I found this issue here, and I'm finding that the reason being is because these nodes on the bottom are not equivalent to nodes on top. You can see that there's a little bit of difference there. My idea to correct this would be to just delete all the elements on one side of that line, and then quickly remesh using the nodes on this side and the nodes on this side to replace all of those elements in the center. And then that should be a very quick way to equivalence those back together and get you back running. But really, I just wanted to show you guys that this is here. If you're ever having that error, the first thing you should check is go into your run directory and see if you've got a mesh intersections file here. If you do, then your mesh is not complete, and this can help you figure out where that issue is. And you'll have to go back and correct it. And then the very, well, this is another thing that I thought I wanted to show. Now, real quick, this is not a part of Virtual Wind Tunnel, but Inspire Studio does come free in the student package. It is part of the free student edition. The reason I just wanted to play this couple-minute video here is because I think it would be incredibly beneficial to you guys who are remodeling your parts to further optimize them for aero performance. You can take a simple sketch here, and within hours, he's using freeform modeling to kind of create a 3D shape around the model. So in a way, this is similar to the morphing tool that we just saw, but you can sort of, if you NURB up your part, like I showed, you can pull it into Studio and kind of reshape all those NURBs, reshape those surfaces like he's doing here, just dragging points around, and reshape your model in this way pretty quickly. And it's just another tool that is available for you guys to work at a faster pace, if you will. So I thought I would just show it to you guys in case you were interested. I think it would be very helpful for any of you guys trying to further refine your aero. With that being said, I don't have any other content. So what I'll do is I will find the links to that content, and I can post them here. And then I will also just stay on if anyone has questions. You can either post them, or I guess you're also welcome to come off mute if that's possible. I'm happy to help where possible.
Thanks, Corey. Yeah, if you could post those, that would be great. And attendees can post their questions in the Q&A. And I see a new question that just came in.
Was there a limit to the size or meshing of models within the student version? So like Darius said, you can't actually access Virtual Wind Tunnel without the Altair sponsorship. The reason for that is because there is a limitation to your element count in the student edition. So if you want to use any of our CFD tools, for example, you will need the sponsorship so that you can achieve the finer element size. Excuse me. But yeah, to answer your question, there is a limit in the student edition. Turbulence modeling in the simulation is automatically selected, right? Correct. So there is not You can actually select turbulence modeling in Virtual Wind Tunnel. It's a very simple tool. But yes, it does capture the vortices there for you. If you really want to dive in and see what's happening inside of your turbulence, that's where I would recommend you go into one of the custom solvers like AccuSolve or ArchiFluidX on their own to run your models that way. To use the Virtual Wind Tunnel interface, it's more or less just calculating the impact those values will have, or that those vortices will have on your model itself. But it's a great way to generate quick initial concepts and start creating your iterations at the start. Once you get to your final design, you want to make sure that you run something in AccuSolve, for example.
Corey, is there an email that you want me to post in the chat if people want to reach out for further information or to get those links from you so you don't have to search around for them?
Yeah, so here's my email. You can also post that in the chat. And then if Darius hasn't mentioned, once you are sponsored by Altair, you can also use this HW support at altair.com, and that'll give you access to any one of our support engineers who are happy to help you whenever you have any questions. And then of course, here's a link to the sponsorship info, which I think is already pasted in the chat. But yes, that would be a smarter idea. I think if you guys are interested in those links or more information, please reach out to me and I'll make sure I send them to you directly, because I'm not sure exactly how many of them or where they're all posted right now, but I can find those at a later time, certainly.
Great. I posted the 2 email addresses, and I will post that sponsorship link as well.
Also, if you guys do want to visit altairuniversity.com, there is a lot of additional information. There's a lot of training material there as well. So if you guys wanted to dive into some virtual wind tunnel content on Altair University, that's also available. There's some kind of self-paced training classes all posted there for you. But yeah, I hope this was helpful for everyone. I did keep it short and quick. Hopefully not too fast, but like you saw, Virtual Wind Tunnel is very, very simple. Once you open it, you'll get the hang of it within a matter of minutes. So.
Great, thank you so much. I don't see any more questions in the Q&A. I just posted some more links in the chat, so we will, as I mentioned at the top of the session, this is being recorded and will post probably in about a week or so on the eFest YouTube channel.
Okay, perfect.
Great. I guess that concludes, Corey, since no more questions have come in. Thank you everybody for attending. We appreciate it. And have a great day.